I think there's a lot of questions around the fishery assessment, Sean.
All right, what do you got?
So there's a lot of questions around the term depleted, saying it seems ambiguous. Is this statewide or is it localised? Is the depleted rating made on numbers or biomass? And is depleted linked to total harvest in each area? And how can fishing effort reduce, but fishers are still having a significant impact? So that refers to that reduction in overall fishing effort, which you've just explained. We can start there.
Righto. Okay, it's working again. So it's almost like I came prepared. How are fisheries assessed? So in Australia, there's a series of criteria that a fishery is put into depending on two major levers. So one is the biomass. So that's the weight of the population. And the other is fishing mortality. So that's the amount of fish that are taken out of that population by fishing. So again, there's a link here, and Jane, I'll give you all these to put together if people want to do some deeper reading on this. But this plot is called a Kobe plot, and it's one of the simplest ways to explain it. I'll walk you through it. So the box here is representing the 4 different states that a fishery can be in. This axis here is your biomass axis. So here is the biomass if we hadn't fished it. So this is virgin biomass, it's sometimes referred to. Here is no fish left. All right, so when you then have a biomass limit, so a B limit. Now it's often in fisheries for a whole range of reasons, and this is a cumulative thing in fisheries science of just experience across a whole range of fisheries, that once you get below 20% of your unfished biomass, you potentially are getting into a danger zone where you're at risk of collapse, and that you need to do something about it. Now, that's reflected here. So if your biomass is above that 20% limit, it's sustainable. If it's below that, it's depleted. Okay, so that's where sustainable and depleted come in. Now, on the other axis, we have fishing mortality, and that goes from no fishing to way too much fishing. And that's an arbitrary value that you'll see when we sort of show the assessment models and what that could be. But one of a limit that we look at is an exploitation rate of 0.5%. So that's where fishing mortality equals the natural mortality. So that's the deaths that are occurring in the biomass equal to what would have happened naturally through predation and old age, a whole range of things, and the fishing mortality equals that, and that is considered a limit that you don't want to get above, where fishing mortality is taking more fish out of the population than natural mortality. So this is where the other term comes from, the other side of it. So this is kind of the driver of what's happening to the biomass, is that if it's below that limit, there's no overfishing. And if it's above that limit, it's overfishing. So if we put those two together and bring it into the box, if you have a biomass that's above our limit, and you have fishing effort that is below our natural mortality or our fishing mortality limit, you have a sustainable fishery. It can be harvested at that rate indefinitely, and you're good to go. If you have a biomass that is above 20%, but your fishing mortality is too high, you're depleting that fishery. So at some point, you're going to deplete it below our biomass limit that we want to be staying above. So this is where Sand Flathead were for several years. They were in this depleting state. So we knew the fishing mortality was too high, but the biomass was still looking like it was okay. That's recently just shifted over. So then if we've got our two zones here where our biomass is low, if our fishing effort is below our target, we're recovering. So that means that we're allowing more fish to grow back into that population, and ideally at some period of time, they will go back up over the biomass limit that we want. If we are overfishing and we have a depleted biomass, we're in a depleted state. So this is where we are, and I'll show you, we've got one of these plots for Flathead, for sand flathead, and this is where we are at the moment. So the management requirement now is we want to be getting into a recovering state. And the way to do that is to reduce fishing mortality. Then over time, we will move back along this axis into a sustainable fishery. So that's how fisheries are managed and assessed in Australia. So I think I've kind of explained that, but again, on the, how the State of Australian Fish Stock Report's done, there is more detail explaining that in words, but I won't read that out because it's kind of just repeating what I've just gone through. I might just pause there because there are a couple of questions that have come through just about the assessment methods, if anyone's, because this is fairly fundamental to what we're about to step into. So
I've got a couple of questions, but they're not really around assessment methods.
All right, well, we might leave those because we'll come back to them.
Well, I'll have those ready for you when you pop up again.
Yep. Maybe the one from John where it says what was the biomass levels of sand flathead year on year since species specific records were kept, and how virgin biomass estimated given that both commercial and recreational fishing was in place well before records were kept for sand flathead, and has the biomass stabilised due to the reduced commercial and recreational effort?
Biomass and virgin biomass are both modelled. We don't count every fish. It's not like forestry where you can go and count trees that you can't see fish. So a lot of it's based on population dynamics modelling. So that's understanding the life history traits, and that's where we get the frame collection to understand age, growth, reproductive potential, and we will go on and show a few more aspects of how that modelling occurs and how it works. But that stuff is, kind of fishery science 101. And, again, I have a little pitch later on for the Science of Fishing unit that the university offers, which is a free course that gives you a bit of a primer to understand how some of this stuff works. So I suggest people that are interested, and are taking the time to watch this and have concerns, it's probably worth having a look at that course. It's really well done. It's just got some neat bits about, some of this basic fishery science work. So hopefully it comes a bit clearer as we move forward.
Sean, I might just say that the biomass, we don't actually come up with an estimate of there is this many tonnes in around the Tasmania. It's actually a relative biomass, and on that scale of your Kobe plot, it's from 0 to 100%. And so biomass is a relative biomass, and what we do is it's a balance between births and deaths and growth in weight. And if we know the biology of the species, we can then say, if the species grows this fast and it's this heavy and they live for this long, this should be what the relative biomass of an unfished population is without any other causes of death. And then when we can compare that to our actual fish stock, then we can have a look at the size structures and then compare the differences between fished and unfished.
Yeah, and so that's spot on, James. That's where we're at currently, is relative biomass, and that's all we need at this point to make the assessment. We can, further down the track when we get more data, convert that to biomass estimates with more advanced models, but it also involves more data. So, we're progressing towards that, but we don't actually need that yet to make, at this point, to make the assessments that are being made.